Hey everyone, Mr. Anderson here, and today we're going to go ahead and start to talk about some work from section 7.1.5 from our CPM Common Core Algebra book. And our job today is going to be talking about the connections between the graph of an exponential function and the equation of that function. We've talked briefly about how to do some of these things before, but today our goal is going to be to formalize some of this and to develop a process so that if we ever needed to, we could use that process 100% of the time to write an equation from a graph. I'm going to use some material that CPM has given us. We're going to use question 7-59 here to guide us. And every single time we do this, we're going to be talking about the info that we have, because it could be different. We will be talking about other representations that we can be thinking of that can help us to guide our equation writing. And then there are going to be a couple checks that we can use to be sure our equation works. So we're going to talk about all those things. We'll make sure that, we'll make sure that every single one of these questions we're thoughtful of, mindful of, and we're addressing them, okay? I put together some notes for us, and again, you see some things from section 7.1.5. We're asking, hey, what are the connections between the graph and the equation? And we can see the specific part of the web that we're going to focus on here today is going to be the graph and the equation, okay? And I took the material from the book, and I modified it slightly to fit it into a table, and so we can kind of organize our thoughts around some of these things that we're seeing. Our goal, use the clues provided in each graph below to find possible corresponding equation in exponential form, that y equals a times b to the x form. Assume that the graph has an asymptote and it is located on the x-axis. So that's a pretty big clue. We're not necessarily going to be dealing with graphs that cross the x-axis, have an x-intercept. Remember, there are exponential functions that can do that and will do that. That just means their asymptote is elsewhere, okay? So we've got this first graph here in letter A, and I'm going to zoom in on this graph, and I'm going to make some notes about some things that you guys are going to see here. The first thing that I notice as I'm looking at this is I see that I have a y-intercept here at 5. Okay, and that's actually really important because it gives me a lot of the information that I need to write my function here. My y-intercept here is located at 5, and you might even recall that's the 0.05, and that's going to be important as we get moving here. But then the other thing that I notice is that I see I've got an itty-bitty slope triangle in here. And some of you might be barking at your computer screens right now and saying, Anderson, this is a curve. This curve can't have a slope, right? It doesn't have a constant rise and a run. And I would just say, wait for it, right? We'll get there. We'll be talking about it. But the slope triangle is really informing because it tells me if I go over 1 and I go up 2, that this point right here is the 0.17. And that's going to help me figure out what my multiplier is, okay? And I'm going to kind of zoom out a little bit, and I'm going to go over to this next piece here, right? So the point goes from, go from 0.5 to the y-intercept, and then it goes to the 0.17. Now remember, we're talking about an exponential, so I do have a multiplier. Okay, so that tells me as I go from 0 to 1, right, I'm just talking about those x's right now, my corresponding y's go from 5 to 7. And remember way back in chapter 5, our work with sequences. The way we can figure out what that multiplier is, that b value, is by taking a term and dividing it by the term that precedes it. Now you could really write this as 7 over 5, and you could leave it as that improper fraction, be totally fine. Or you could do this maybe the more common way and convert it to 1.4. Okay, now remember, I already identified that as our b value, right? Here's our b, right? We're going to go around here. Their b is going to be 1.4. The other piece that's worth remembering is the y-intercept is our starting value. And that, ladies and gents, is a. The value when x is 0 of y is our starting value, and that's a. And that gives me everything I need in this problem to write my equation. Y equals ax to the b is the format. I said ax to the b. ab to the x is the format. And I can write that as y equals 5. I'll use parentheses for this, times 1.4 to the x power. And there is my function. There is my exponential function. Now, how could I go ahead and check this? Well, got a couple options for you. We could use Desmos. We can go ahead and we can graph these 2 points on Desmos. We know how to do that. Make a table, put in the 0.05, put in the 0.17. Then in the next line, I can graph what I believe to be my function, y equals 5 times 1.4 to the x power. And they should, those 2 points should be intercepted by the graph that we just made, right? And I promise you, if you guys do that, that'll work here. The other thing that we can do is we can take these 2 points individually and plug those things in. And I'm not going to do that for you, but I'll show you how I would do it here. I would ask myself this question. I would say, hey, what does y equal when I plug in 0 for x? And I'd say, hey, what does y equal when I plug in 1 for x? And as I go through and I check these, I better get out 5, and I will. And as I go through and check these, I better get out 7, and I will. Okay? We're going to keep on keeping on because there's some other examples that I want to get to here that look different. And ladies and gents, that look different and will treat us slightly differently. Okay? In letter B, B is our next problem. I've got a decay function. I've got a decay function. If you'd like to pause the video and maybe kind of see if there's some clues that jump out at you in this graph. Okay, but I've got a decay function here, and one more time I see a dead giveaway. I see that y-intercept. That's a pretty nice feature, right? I recognize that as 0, 40. Okay, because when x is 0, y is 40. Now, nothing over here to the right of that y-intercept doesn't mean, we're dead in the water, but I've got something over here. What's this? Well, I'm going to go ahead and remind you that I can take that up, I can take that over, and that means I've got a point there at -1, 120. Okay, so the first thing that I want to document is that my y-intercept is 40 there, and remember, that's my value of A. Okay, spent a little more time talking about that in the previous example in A. Back up if you need to, but that's my A value there. Okay, so I kind of have half my equation written. The multiplier, though, my value of B, the thing that we're going to be doing repeated multiplication with, that's going to require a little bit more work. Okay, I've got to do some thinking here, and the thinking, I promise, isn't too bad, because we're going to do this the same way we did A, but it's, as I mentioned, slightly different, okay? I notice I went from -1 to 0. And as the graph did that, my y's went from 120 to 40. Okay? And because these two things are consecutive, I can go from one term to the next term. And then I say, okay, well, the way, remember, we get that multiplier, that B value, is I take 40 and I divide it by the term that precedes it. Now, like I said before, you could write this as you could write this as 40 over 120, and you'd be fine. And some of you are even going to say, well, Anderson, if I type that into my calculator, that's 0.3 repeating. And if you did that, that would be fine. But because this is a non-terminal rational number, meaning one that doesn't have an end to it, we would probably best be served by writing this in reduced fraction form. And the 1/3 value there is the way to do that. Now I've got my A, I've got my B, and I can go ahead and I can write this as y equals A, I'll use parentheses again, to the x power. And if I'm going to raise that to an x power like I've done here, I have to have those parentheses. Okay? I have to, because otherwise I'm only delivering that x exponent to the numerator there, right? Okay, and you could check those the exact same way we checked the other ones. All right? As we move into part C here, ladies and gents, some things are going to look very, very familiar, and I think you guys are going to see where I'm coming from. If not, please ask. Okay? But some obvious things right now, I made a purple dot. One thing I noticed is that my y-intercept is 7. okay? And of course, that means my A value is 7. We're going to need that in just a moment. All right, but the other thing I notice is that I go from 7 to 56, right? I go from 7 to 56 way up here, but it doesn't just happen in one multiplication. That's not the point 156, that's the point 356. So like there's a 1 here, and there's a 2 here. And what that informs me of is that they multiplied by something to get to the point 1 something, question mark, and then they multiplied by that same something, because that's our rule with an exponential function, to get to the point, oh, I don't know, 2 something, question mark, and then they multiplied by that same something to get to the point 356. So I've got to treat that kind of, importantly here, and it's going to kind of inform my decision making. Normally we just say, all right, they go from 0 to 3, and then they go from 7 to 56. All right, so Anderson, I'm just going to go ahead and take 56 and divide by 7, and when I do that, I get 8. Now, my multiplier is not 8. I don't have 8 as a multiplier. But you're like, but 56 divided by 7, Anderson, that's 8. Yeah, they multiplied by something 3 times to get 8, and that something needs to be the same. So let's go do a little critical thinking here. I multiplied by something, something else, and something else, the exact same thing 3 times, and I got 8. So ask yourself this question. What number, again, multiplying by 3 times, what number can I multiply by 3 times and get 8? Did you guys figure it out yet? Do you see it? Here's your answer. There's your B value. Okay, and I promise again, folks, these checks are going to work. And if you don't believe me, I encourage you guys to use them. That means my equation is y equals a times b to the x. So my a value is 7. My b value is 2. And there's my exponent, a times b to the x. All right, like I said, Desmos will help you check that. Your scientific calculator will help you check that, right? A couple options that we have. All right, last one of these, and this one is going to be, maybe pretty boring, but it might help you see something that we've been talking about for a while. Okay, here we go. We've got another exponential curve, and you're going, you're crazy. You're concussed, Anderson. You bumped your head. That's not an exponential curve. That's a horizontal line. I'm going to stand by what I said. That's an exponential curve. Here I go. Let me prove it to you. All right. Here's what I notice. I recognize that in this particular case, we've got a y-intercept of 18, right? Because that's what this is. Like when x is here at 0, this is the point 0, 18. There's my y-intercept. You got to give me that, right? You have to. But what else do we got? What else do I notice in terms of my multiplier? Well, I notice that we go from, as x goes from 0 to 1, the y's go from 18 to 18. Now, I don't have to treat this like letter C because, after all, this is just one step. It's one multiplication. They just multiplied by one b value to get from there to there. I'm sorry, I said 1. I got to backtrack on what I said. That's a 5. Yikes, Anderson. All right, so 1, 2, 3, 4, 5. Okay? But what I notice is that the y value does not change. And I'm going to treat this just like I did in C then. I'm going to take 18 and divide by 18, and this is going to be not very exciting. It's 1. Okay? So what number can we multiply by itself 5 times and get out 1? You got it? Do you know what it is? Ding, ding, ding. My b value is 1. Okay, 1 times 1 times 1 times 1 times 1 is 1, right? It's our multiplicative identity. And that is why, ladies and gents, this one, because multiplying by 1 never changes something, that's why this is not, well, like I said, it is an exponential curve, but that's why it's not a decay or a growth function. It's a constant function. It's a line, right? So here I go. Y equals my starting value times 1 to the x power. And like I said, those checks will hold up for you. And if you don't believe me, try them out. Okay, folks, a couple review preview problems for you. 62, 63, and 66. Give those things a shot. Remember, they're going to let you know what kinds of questions you have. Don't be afraid to follow up on asking. Thanks for watching.